Hello everyone, today we're going to talk about this 269th question on Leetcode, Alien Dictionary. There is a new alien language which uses the Latin alphabet. However, the order among letters are unknown to you. You receive a list of non-empty words from the dictionary, where words are sorted lexicographically by the rules of the new language. Derive the order of letter in this new language. So we look at the first input. It is WRT. WRF, ERETT, RFTT. The output should be WERTF. So WE is from the second word and third word, so it's W before E. And E before R is the third word versus the fifth word, so it's E before R. And then T is before F, for the first word T to the second word F. And R is before T by third word and fourth word, but the second letter is R, and so the third word for the second letter is R, and fourth word for the second letter is T. So this is WERTF. And then for input ZXZ, we know that Z is before X, but it also says that X is before Z, so there's a contradiction, and we output just like empty string. Yeah, so this question is a typical topological sort question. So what we're going to do is that we're going to build a graph based on the information given to us and try to run the DFS, which is also topo sort, on this graph, and then to see whether there's a valid dictionary ordering or not. So let's just look at example. Second one is easy to see. So first we see that Z is before X. So we have a node Z, and then we have a node X. Z is before X. We draw like edge from Z to X. We also see that X is before Z. So we draw edge back. So if we see such a cycle in the graph, we know that there is no valid ordering. However, let's look at the first example. So first we compare the first word to second word. So if we see that the letters are the same, so we're just gonna skip them. So we compare the first letter, we find that letters are the same. So we compare the second letter, we find that letters are all the same too. But we compare the third letter, this is T, this is F, which means that T is before F. And we compare the second word to third word, we know W is before E. Since that first character are different for second and third letter. And for third to fourth, we see that R is before T, because this letter and this letter are different. So this is R before T. And then for the final two words, we see that E is before R. So we draw the edge back. So the topological ordering should be W, E, R, T, F. By the way, the so-called topological ordering just means that if there is edge between node A to node B, then node A has to, in the ordering, node A has to be before node B. So this one will be WERTF. So, in a summary, first, we're gonna build a graph based on the information we are given. Second, we'll run a DFS algorithm to see, that's first search, to see that whether there's a cycle or not. So if there is a cycle, we return the empty string. If there's not, we're not gonna finally output the correct ordering. So this is a hard question on Leetcode, which is kind of hard to solve. However, I encourage you to try this question. And then if you do not have a clue and Okay, so for this question, first we're gonna initialize two variables, boolean for adjacency list, actually adjacency matrix, and int for visited new so to keep all the possible letters we could visit. And then first build the graph. And for this function build graph, we take in string of words, a string array of strings for words, and then adjacency matrix, and then visited array. So first we initialize all the visited value equal to -1, which means that this letter we haven't seen yet. And then for each word, we're gonna set the word we see the value to 0, which means that letter exists. So and then for two words, we're gonna compare words one by one. So we have a word W1 for words I-1 and W2 for words I, and length should be the minimum for those two words length. We compare each character, and then we find out the first difference in characters for these two words, and then set the adjacency list, adjacency matrix for those two words to be true, and then we break it. This is the build graph state. Then we initialize string builder. So for each possible letters, if visited are equal to 0, means that it exists, the letter exists, but haven't been visited yet. We're gonna run DFS on this character. When we run into a DFS, we first say that the visited are equal to 1, which means that we are visiting this character. And then we run through 26 different characters, different letters, and say that to check the adjacency matrix to see that whether it's a neighbor of this current letter or not. So if visited of j equal to 1, which means that its neighboring is being exploring at this stage. We know 0 exists a loop, so we return false. And if we return false at this stage, we're gonna just return the empty string, which means that there is no valid ordering for this dictionary. However, if it is equal to 0, means that this neighbor haven't been visited yet. We're gonna run DFS on this neighbor, and then it's gonna loop until we reach the letter such that it doesn't have neighbor which hasn't been visited, and we set this letter to be equal to 2, which means that we are done visiting this character, and then we just append this to the string builder and return true. So finally, if we never hit this condition for any round of our recursion, we know there should be a valid ordering. And then we do sb.reverse.toString. Why do it in reverse? Because let's take this example. We have A has an edge to B and B has an edge to C. So we know that by this DFS algorithm, C is the first one done with visiting. So we'll just set the first visit of I, which in this case visited for 3 equal to 2. And then we're done visiting C, so we add it to the string builder. And then we add B, and then we add A. So this is SB contains the letter CBA, but we want ABC as the correct ordering. So this is sb.reverse.toString. Thanks for watching. I hope this kind of help you to understand this question, and enjoy your day. Bye bye.